Howdy. I just recently talked about the Gorringe Ridge, or however you want to pronounce that. That's in the extremely rare cloud phenomena occurred 3 days in a row video, which is probably my last I did. And I found, so to say, the Gorringe Ridge because I spotted one single lightning bolt yesterday. And today I went over to Google. No, it was windy, and I just watched the weather situation in Europe, and I noticed something rather interesting. Let me show you that quickly. So that's a screen recording I made earlier today. Maybe you have seen it. There was a lightning strike, and now we have all of a sudden some clouds appearing at the same place where I spotted the lightning strikes, where approximately the Gorringe Ridge is situated. And there's also something going on here. I think I zoomed in a bit, yeah. Here you can just all of a sudden see clouds emerging, and there are some lightning strikes basically out of the blue sky. One lightning strike. Anyway. And first we have a cloud band emerging here. But the Gorringe Ridge is somewhere here. But check it out. There is something emerging there too. And there is the lightning strike. It's a bit hard. There was another one. One on the left. And then one here in the center of the screen. But anyway, now we have seen. And these are from today. Let's go on with the video because I recorded also the La Palma. Because there's something going on as well. And it's not on an island, it's in the water. Out of the water, all of a sudden, there are like clouds emerging. We could go over to the National Data Buoy Center and check it out if there's anything there. Probably there is. And I would even classify this cloud emergence as something volcanic. Jewel antennas from under the ground, in this case. Undersea, there is something going on. Because there is no island. But we have to assume that there is volcanic activity nonetheless. Most of the volcanoes probably on Earth are submerged within the seas anyway. So those we can see with bare eyes, which are mountains on land, yeah, it's not even the half of the story. So as we are talking about volcanoes and stuff, let's go quickly over to clay. Because for those who don't know yet, I have been in a laboratory some time ago. And I showed them some pebbles which have been in the microwave. There has been also some auroral display over Iceland some time ago. And I made a video about that. Which has the name Following the White Rabbit. I know stuff I probably am not supposed to know. Yeah, stuff like this. Results from an electron microscope. Yeah, I would call this science. you know, making art. But anyway, that's a part of the melt which got produced in my microwave experiments, analyzed by an electron microscope. We have potassium, calcium, oxygen, iron, salt, magnesium, aluminium, silica, and more potassium and calcium and iron. Just in this, and there have been many of these parts we checked out, but unfortunately I didn't get the end results, so I have to deal with what I have, which are some pictures I made during my visit to this laboratory. And then I got this paper also written. This is a result from a Raman microscope. Raman. Let me show you. It's, I think, in the beginning. That's the electron microscope. And that's the Raman microscope, where the paper got from. Let's say it like that. So, it took me several weeks in order to get my head wrapped around the results, because somehow I was rather focused on copper and sulfur and stuff like that. So, the result was a bit strange, because there hasn't been any sulfur or any copper in this. So I was like, yeah, what to do? What's that? This has to mean something. So it turned out actually that this is basically clay. So now we have to talk about this in a, how to put it, open-minded way, because my microwave experiments means that I have been putting pebbles in the microwave and see what happens. Some of them didn't do anything. Some of them, they just turned like a little bit warm, and that was it. Some of them, they started to melt. Some of them started to burn. And we had even plasma discharge events in the microwave. Once it even almost started to burn, because there has been established an arc. But anyway, that was the constituency of one of the melt, and you can check the other video. I will put a link below. You'll probably know more after that. So, I also have been talking where you saw the auroras over Iceland. About that, I have to talk about Iceland once at least, through my experiments with the microwave, because Iceland, I don't know, many people think there are many volcanoes on the Iceland, but I think it's just one big volcano with many vents, many different kinds of vents. It's just one big volcano. If you look, like, let me show you. So where are we? That's Iceland. It's one blister with many, many vents. And it sits on the Atlantic Ridge. Which goes all the way up here. And here with the Azores which connect, we have a triple junction here, so energy is probably flowing that way. Usually. Northwards. And there has been quite some activity recently, solar-wise, earthquake-wise, whatever-wise, weather-wise. And we had the auroral display, which I thought, or I still think, could have been over the mid-Atlantic Ridge or North Atlantic Ridge. And there has been some earthquake activity a few days later, somewhere here. Let's zoom out still a bit more. If you are standing here and look in this direction, let's say it's southwards, and the auroras, this is not really in any kind of proportion, but the auroras are somewhere over here. And then you should know how big they are, and then you could, in a way, measure how far away they were. Then you will know the place at the ground above which they appeared. But since we don't know the size or the distance or the height of the auroras, we can only guess. But I think they could have appeared somewhere over this ridge, where we had later the earthquake activity. So now, this might be just one giant volcano, which is the little brother of this one, which is Greenland. Yeah. Thinking about glaciers and them being actual lava streams made of water, then we probably could think about Greenland in a different way. But that's not part of the discussion now. Let's go to Iceland. I found a paper, Volcanic Soils of Iceland, Ólafur Arnalds, Agricultural Research Institute, Kellenraholt, Reykjavik, Iceland. Abstract. The parent materials of all Icelandic soils are volcanic in origin, and most of the soils are classified as andosols. Iceland has the largest area of andosols in Europe and may have less than 5% of all andosols in the world. A new classification scheme based on the World Reference Base for Soil Resources, World Soil Resources Reports 84 FAO Rome, is used to provide an overview of Icelandic volcanic soils. The data were acquired as part of a recently initiated effort to build a database for Icelandic soils, but are also partly based on data from the EU COST 600 Action, a literal review and unpublished Icelandic research. The main soil types in Iceland are histosols, histic andosols, glacic andosols, brown andosols, vitrisols, and leptosols. In the Icelandic language, a single term is used to refer to each soil type. This system reflects the dominant influence of aeolian deposition and drainage conditions of the formation of histosols and andosols. The parent materials of Icelandic soils are mixtures of tephra layers and aeolian sediment, consisting mostly of volcanic glass. When I have been there in this petrological or geological laboratory, we were watching this piece, as you can see in the video, with this very cool binocular microscope. We were looking into the melt, like from the inside. And because it was a very cool microscope, we really could see in it. And everything was glass. The whole surface was glassy. And not only that, it has been very, very colorful. Despite the melt, if you just look at it from the outside and with bare eyes, it's just gray or silvery, black, silvery, grayish. But it's shiny. And I think it's because of the high aluminium content. But from the inside, with a microscope, it was very colorful. Unfortunately, I don't have any pictures or whatsoever I should have taken, because it was amazing. I didn't really expect that. The histosols, less than 20%. No. The steady flux of aeolian sediments from unstable sandy deserts constantly recharges the surface with basaltic tephra materials. The histosols, less than 20%. Celsius? No. Calcium? I don't know. Have appreciable amounts of andic materials because of the aeolian deposition. We just have to go a little bit on, because there's another word I wanted to show you. The andosols, histic, glacic, and brown andosols show characteristic properties of soils dominated by andic materials with allophile contents of up to 30%. Now, we have the word allophane and andosols. Let's look them up. Because I don't think these are everyday language words. Probably heard them the first time. Probably I heard them the first time too. So that's why I went to look it up. What are they talking about? Andosol. We are at Wikipedia, which is free for everyone. Andosols are soils found in volcanic areas formed in volcanic tephra. In some cases, andosols can also be found outside active volcanic areas. Andosols cover an estimated 1 to 2% of Earth's ice-free land surface. Andosols are a reference soil group of the World Reference Base for Soil Resources, WRB. They are closely related to other types of soils such as vitrosols, vitrandosols, vitrans, and pumice soils that are used in different soil classification systems. The name comes from Japanese and dark and do soil synonymous with kuruboku. In the USDA soil taxonomy, many andosols belong to the order of the andisols. However, the definitions are different. Some histosols belong to the andisols and some andosols belong to the inceptsols. Yeah, this sounds very complicated. Now, let's just read from here in order to save your nerves. If the tephras are more basic, or the climate is dry, amorphous colloidal materials, including allophane and immoglite, develop, and the andosols are giving the Icelandic qualifer. Now that's geology, you know. That sounds all very complicated. There's like 1,000 words you should learn in order just to understand what's going on. But now we have it again here. Allophane. So now that's from the paper, andosols and allophane. These were the two words I wanted to show you. So allophane, let's click on this. Allophane is an amorphous to poorly crystalline hydrous aluminium silicate clay mineraloid. Its chemical formula is LaL2O3 silica and water. Yeah, I'm not a chemist, so for chemists this might be much clearer than to me. But anyway, since it has a short-range atomic order, it is a mineraloid rather than a mineral and can be identified by the distinctive infrared spectrum and its X-ray diffraction pattern. It was first described in 1860 in Grafenthal, Thuringia, Germany. Allophane is a weathering or hydrothermal alteration product of volcanic glass and feldspars and sometimes has a composition similar to kaolinite, but generally has a molar ratio of aluminium silica equals to 1:1, maybe 50-50. It typically forms under mildly acidic to neutral pH. Its structure has been debated, but it's similar to clay minerals, and it is composed of curved aluminium octahedral and silica tetrahedral layers. Transmission electron micrographs show that it is generally made up of aggregates of hollow spherules, 3 to 5 nanometers in diameter. Allophane can alter to form halloysite under resilicating aqueous conditions and can alter to form gypsite under desilicating conditions. A copper-containing variety, cuproallophane, has been reported. So for those who have seen my copper videos and for those who have seen already the clay video and know something about my other stuff, reading copper here and all these kind of things, kaolinite, that's all very interesting. They all very nicely tie together into the whole thing. Aggregates of hollow spherules 3 to 5 nanometers in diameter. Let's go quickly back to the rabbit video. I call this the rabbit video. Let's just listen to what I said in the video back then. One of the melts. Yeah, it looks like the moon. He tried to measure something here, and then it exploded. The same thing happened. Maybe it was this one. Or this one. I haven't seen them exploding, but he did. I just noticed that there was a different one. And then it turned out that he was putting the beam on that. I think here is visible better. That one exploded as he tried to measure, and this one exploded as he tried to measure. Yeah. We just read about the sphericals, which are very small. And here is micrometers, or 100 micrometers, so the smaller ones are rather small. If this is 100 micrometer. So the thing is, the melt which poured out of my stones, which got produced with a microwave, is in a way quite similar to what is pouring out of Icelandic volcanoes. And they are quite literally fed by telluric currents which are flowing through the mid-Atlantic ridge. So it would be no surprise to have an auroral display over the mid-Atlantic ridge if there's an energy peak or spike. And as we have seen, it just started to erupt and it just dropped. So we could maybe think that there has been an energy peak. So if there's more electricity all of a sudden flowing through, it might erupt again. All of a sudden. Due to the induced currents, as happened in my microwave experiments. Just on a bigger scale. Yeah. But anyway, I think I'll leave it here. This has been a very long video once again. Yeah, there has been some clouds in the beginning, and now we are looking at bubbles. Yeah. Thanks.